Here we will do a QR factorization with the given rotation. So let's rotation. Let's say we have our matrix A, and it is equal to 1, 1, 2, 2, 1, 1, 0, 1, 0. Okay, and now we will try to do a QR factorization with the given rotation. Okay, so first we will try to eliminate this element here, then this one, then we will go to the second column vector of A, and we will try to eliminate this one. Okay, remember that our given rotation is given by cosine minus sine, sine, cosine. So remember that C stands for cosine and S for sine. Okay. And remember also that generally we don't need to find the angle. Let's call it phi, or call it whatever we want. We're not interested in the angle. And remember that the minus sign is always in the place of the element you want to get rid of. So here it will be the place of the 1 in purple. Okay. So remember that our cosine is equal to the element at the top of the vector. So here it will be the first one of the first column vector of A. So 1 over the square root of 1 squared plus the element we want to eliminate, so also a 1, so 1 squared. And our sine is equal to the element we want to eliminate, so here 1 over the square root of this element squared plus the element at the top, so it's the inverse of the formula for the cosine. So we get our two values. Remember that these two formula come from basic trigonometry. Remember that cosine is adjacent over the hypotenuse and sine the opposite over the hypotenuse. And basically here you consider only two components of the vectors. So if here we have vectors with 3 components, so in a 3-dimensional space, but we can still form a triangle if we consider only 2 of these 3 components. Okay, let's say you have a given vector in 3 dimensions. It has 3 components. So let's say these are these 3 components. So this is Z, this is Y, and this is the X component. If we only consider 2 of these components, let's say only the Z and the only the X and the Y component, we can form a triangle. Okay, or if we take the Z and the X component, we also get a triangle. Or yeah, the Y and the Z, we also get a triangle. Okay, and it comes from there basically. You only consider 2 of the vector components. Okay, I just wanted to make that clear. Okay, so let's do our computing. We have values here. We'll get for cosine, it will be roughly 0.707, and sine will be the same thing. Okay, So it's 1 over square root of 2, it's square root of 2 over 2, so it's an angle of 45 degrees, if you want to see it that way. And so we said the minus s in our matrix is always in the place of the element you want to eliminate. And here also, to eliminate the y component of the first vector, we will rotate around the z-axis. So there is a 1 in the z-axis. Okay? So let's construct our first given rotation matrix. It will be 0.7 minus 0.707 0.707.000. I don't write the 0 before the point because otherwise it takes too much space. We could write it, of course, doesn't matter. And so if we apply it to A, we will get, so you can do the computation if you want, we will get this matrix here. So here is just matrix multiplication, minus 1.707 and 0. Okay, this point here. Okay, now we want to eliminate this element here. Okay, so we will redo our formula. Cosine is the top element of the vector, so 1.41 over square root of that element, 1.41 squared plus the element we want to eliminate, so 2 squared, so 2 squared. Okay, and this will give us roughly 0.577, and our sine is equal to the element we want to eliminate, so 2 over square root of 1.41 squared plus 2 squared. Okay, so 1.41 squared, the top element of the vector. Okay, which will give us about 0.816. Okay, and now our second given rotation, G2. Remember, our minus sign is always in the place where we want to eliminate the element. So here our matrix will be minus sine 0 cosine 1 0 0 0 sine and cosine. I hope you can read it. Okay, and here also it does make sense, because if we want to eliminate the z component, the first vector, we will rotate around the y-axis. Okay, and so if we apply that to our result, let's call this result A1 because it's the first result, the first given rotation. So if we apply G2 to our first result A1, we will get this matrix here. So you can again do the computation yourself. This is just matrix multiplication. This is We'll try to rewrite it a bit better. This should be correct, and so we'll get A2. Okay. Now we will go to our second column vector and eliminate this vector. Okay. Now, here we will be careful because our goal is to get an upper triangle matrix. Remember, and if you are in a 3 by 3 matrix case, our second column vector only should get rotated once. We only want to get rid of one of these elements. And what we do is, if we go to the second column vector, we only consider this 2 by 2 submatrix. We will only consider this matrix here. Okay? For the householder transformation, we have to do the same thing. Once you go to the second, then to the third, the fourth, and so on column vector, you only consider the submatrix. I think I didn't say that in the first video, but now you know it. So basically what this will change is just that our top element of the vector will be the top element of the vector in the submatrix. So here, in our case, the top element of the second vector in the submatrix will be this one, not the top element of the original vector. So our formula changes a bit because our cosine will be equal to the top element, but here in the submatrix, so it will be minus 0.707 over square root of, plus the element you want to eliminate, so this doesn't change. This will get us minus 0.523 roughly, and sine will be equal to the element you want to eliminate, so minus 1.15 over the square root of minus 1.15 squared plus our top element, so in the submatrix, minus 0.707, which will get us 0.851. And so what doesn't change is that our minus sign is still in the place of the element we want to eliminate. So here, so our third given rotation will be given by 1, 0, 0, 0, 0. Our minus sign will be in this place, so we have 0.851 minus 0.523 minus 0.851 minus 0.523. This 0 should be a bit more to the right. Okay, so remember our minus sign is where our element is that we want to eliminate. And also, if we want to eliminate the z component, we can here in this way we can rotate around the x-axis. Okay, maybe you want to know why couldn't we also rotate around the y-axis as before? Why couldn't we just do couldn't we put a 1 in the second component and the y component and rotate around this axis? The problem is we said that our minus sign has to be in the place of the element we want to eliminate. And if you put it here, we can't put a cosine on the top because there's already a 1. The ones have to be on the diagonal. Otherwise, if you multiply it again with the matrix A and the ones aren't on the diagonal, the diagonals, the one on the diagonal, basically they are here to guarantee that we won't again get a non-zero element in our first column vector, here in this case, because you are in a 3 by 3 matrix, okay? If the ones aren't in the diagonal, there is a risk that that the vectors where we already have zeroed out some elements, that they will get again some zero elements, some non-zero elements, and so we need ones in the diagonal, and here if we put the minus sign at the place it should be, but we rotate around the y-axis. I said the 1 should be on the diagonal, otherwise we get a wrong result. We don't get the result we should get. But at this place there should be the cosine also, so this won't work. Okay. So thus we need to rotate around the x-axis. Okay. So here is our third given rotation, and if we apply it to A2, get A3, which is roughly 2.4400. We'll get roughly that, okay? So this is 4, sorry. Okay, and so we get that, remember, all these matrices applied to A give us our upper triangle matrix, and because we know that Q transpose A is equal to R, we know that this here is Q transpose, and so we could take the transpose of this free given notation, of the product of this free given notation, and we could get Q. Okay, you can do that on your own if you want. Yeah. So I hope this video was helpful. So remember, you just remember the given rotation is just basic geometry and trigonometry. The minus s in the formula is always in the place of the element you want to get rid of. Be careful if you choose around which axis you want to rotate, because you have to be careful. You have to look that the ones are always on the diagonal, okay, and that they don't, let's say, interfere with the cosine and sine, okay. And yeah, thanks for watching.